algebra is the ability to carry out substitution effectively. And at least at the start, it's all about substituting into either an expression or a formula. So we're going to look at those in this video. Suppose we think about substituting into an expression first. The question might say something like this: find the value of 3a plus 2b if a equals 5 and b equals 7. Now, in this question, what you do, you start by just writing out that first line. There's no possible excuse for saying you're stuck if you haven't written out the first line. Drop down a line, move a little bit to the left, and put an equal sign. And then just drop everything down underneath where it was originally. 3. A is 5, but 3a means 3 times a, so 3 times 5 plus 2 times of b. Now you need to remember BIDMAS, which tells you that the multiplications are much more important than the addition. That addition can wait till later on. So I'll perhaps just copy the plus down and concentrate on getting these multiplications right. And then I can put the final answer of 29. That is how you substitute into an expression. The expression might be a lot more complicated. You could have something like find the value of a squared minus 5b when a equals negative 3, b equals negative 4. So this is more complicated, partly because we've got a square, partly because we've got lots of negatives, but the principle is the same. You start by writing out the piece of algebra that you've been told to work with. On the next line, you substitute things in. So the negative 3 is going to be squared, and we immediately have to be careful. It's not just the 3 which is being squared, because this isn't a 3. It's a negative 3. Negative 3 and 3 are completely different numbers. And so when we square the negative 3, then it's wise to put it into brackets. Take away 5 times negative 4. Now, let's think about this. When you square something, you're multiplying it by itself. Negative 3 times negative 3. Now, you should know that a negative times a negative makes a positive. So negative 3 times negative 3, or negative 3 all squared, just makes positive 9. And here, let's deal with all of that in one go. Minus 5 times minus 4. We've got the same thing going on. A negative multiplied by a negative. Minus 5 times minus 4 makes positive 20. And so the answer is 29. It's a coincidence that that 29 is the same as this 29 in the previous example. That was rather unlikely. Let's also just look at a slightly different way of thinking about this example here. I'm going to do it one more time. A squared minus 5b equals, same second line, minus 3 all squared, take 5 times negative 4. Negative 3 squared, as discussed, makes positive 9. Now up here, I included this negative with the 5. Negative 5 times negative 4. And because I included it in the whole sum, therefore I didn't copy it down. But if I want to copy it down, I can do this, but I mustn't use the negative twice. If I copy it down, then I need to treat this as a 5. 5 times negative 4 makes negative 20. And a double negative like that makes a plus. And so we've got 29 again. Both of these are okay. I actually prefer this one because it's more precise to regard this as being negative 5 rather than a 5 with a takeaway stuck on the front. But they do both work. So substitution into an expression always works like this. And perhaps the key thing to notice is that there's always an equals sign down the left-hand side. If instead we substitute into a formula, it looks very similar, but there is an important difference. An example, and I'm going to use something that looks very similar to what we did over here. Find the value of t if t equals 3a plus 2b and a equals 5, b equals 7. So you can see a lot of similarities between this question and this question. You can see the 3a plus 2b. You can see that I've given a and b the same values. The difference is this capital T. This is a formula because it tells you how to make the value of t happen out of this. This is just a lump of algebra expression. But again, the principles remain the same. Copy down the algebra that you've been told to work with. Copy down everything underneath where it belongs. But that now includes this capital T. It's going to get copied straight down to there. We don't put an equals on the left-hand side because we now have an equals running down the middle of the formula. That makes 15. That makes 14, and there's a plus in there. So t equals 29. Huge similarities with this first one, but it is different, and it is quite an important difference. Let's think about why it's an important difference. Suppose you were given the following question. Suppose you were given a rectangle and you were told that this was 5 centimetres and you were told that this was 20 centimetres squared, the area was 20 centimetres squared, and you were asked to work the height, which we're calling. You should know how to work out the area of a rectangle. Base times height is how you work out the area of a rectangle. And so you can see fairly quickly, I think, that the height is 4 centimetres. That's not the point that I'm trying to make here. You write out the full formula for the area of a rectangle, not just base times height, but area equals base times height. And you now substitute in the values that you've been told. 20 equals 5h. So whereas in my first example, we were working out the value of t and it was already on the left-hand side, now we're working out the value of h and it's tucked up inside the more complicated bit of algebra. The a equals, we know the area, and we just drop that value into the left-hand side there. 20 equals 5h. And then you need to know how to solve an equation, which isn't the point of this video. We're just looking at substitution. But if we do continue it further on, 5 times h, we want to know what h is, so we do the opposite. It's being multiplied by 5, we divide it by 5. And we do the same to both sides of the equation. So h, one single h, equals 4 centimetres. But the key thing here is that you know how to substitute into the equation. Yes, you can do that one in your head, but very quickly the questions become too difficult to do in your head, and so you need a standard method. This is it.